Section 6.2 of the guided notes. Understanding quadratic functions of the form g of x is equal to a times x minus h squared plus k. And your luck, we kind of started our chapter doing this already. So this, by the time you get to these notes, this won't look that goofy to you at all. You've already done this. So every quadratic function can be represented by an equation of the form, g of x is equal to a times x minus h squared plus k. The values of the parameters a, h, and k determine how the graph of the function compares to the graph of the parent function, which is basically y is equal to x squared, or f of x equals x squared. Either one, they're interchangeable. Now use the method shown to graph basically. So we are going to graph two. Let me rephrase that. This is the function g of x is equal to 2 times x minus 3 squared plus 1. And hopefully you remember from all the stuff we've done this week already, right? There is a, that is h, and that is k. So I know for certain, right, this graph compared to its parent is going to move up 1, to the right 3, stretched by factor of 2. Right, so that's here. And then I'm going to draw the parent function in red. Right, we've got 0, 0, 1, 1, 2, 4, 3, 9. And it has a symmetry, so it's going to match up on the other side. And right in red here, this is the parent function. All right, parent function. And now in purple, right, let's see, this thing's going to have a vertex. It's going to have a vertex of basically 3, 1. So 1, 2, 3, 1. And then the point 24 is going to move to 2, 8. And I think this is just describing, well, if I had this thing y equals 2x squared, right, it would be stretched like so. Right, and then the whole thing would be moving, 3 this way and up 1. So that the final graph winds up being, well, let's see here, something like this. And it's been shifted. All right, so this is to indicate, I know there's a lot going on here, that it's been stretched and then it's been moved to the right 3 and up 1. All right, so then this graph here in green, this represents 2 times x minus 3 squared plus 1. So when I scroll down the page, my graph is going to disappear. But, right, this became 2, 8. It was a factor of 2 that point moved to 5, 9. And I don't know if you can tell here, but between 2 and 5, right, there's 3. And between 8 and 9, there's 1, right? We moved right 3 and up 1. So that kind of makes sense. And let's see, the vertex of the graph of f of x squared is, right, this part right here is 0, 0. While the vertex of the graph of this function is 3, 1. Okay, and that's all right. That's kind of stuff I already called out in the prior section above. So vertical translations. A vertical translation of a parabola is a shift of the parabola up or down with no change in shape. And we've actually already done this on the worksheets, but this is the formal notes for that. So the graph of the function f of x is equal to x squared plus k is the graph of f of x equals x squared translated vertically. Right, if k is bigger than 0, the graph moves up. If k is less than 0, as in negative, right, the graph moves down. Positive, the graph moves up. Hopefully you remember this from absolute value, and you'll be like, oh, I know I complained about that section, but oh, look, isn't it nice? All the rules still apply for these other functions that I learned. Thank you to Mr. Minton. Yes, I know. It is nice, right, that we've already seen this all before. And now I don't have to relearn this all because everything that you've already learned applies to this new function, quadratic function. So let's engage in an activity here on this example. And we're just going to draw the parent function, right? We've got, 0, 0, 1, 1, 2, 4, 3, 9. This is the basic quadratic function. And there's its shape, right? Negative 3 squared is 9. 4, 1, 0, 1, 4, 9. Those are all the points I just graphed. Well, if you're moving them down 5, right, because that's what this indicates, down 5, well, all you really have to do is move everything down 5. Well, what is 9 minus 5? What is 4 minus 5? What is 1 minus 5? 0 minus 5? 1 minus 5, 4 minus 5, right? And there's that symmetry again. So the graph of this function here, right, is all we did is we subtracted 5 from everything in this function. And that's exactly what you do. So literally, if I take every point here, let's say, right, this is our parent function, and every point is being shifted down 5. 1, 2, 3, 4, 5. There's the new point. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And you get the idea, right? I mean, it's just been moved. It's been shifted, translated. And here is the translated parabola. The shape didn't change, right? We just moved it down. Oh, translated vertically. So it has a new minimum value. Instead of the minimum value being 0. The new minimum value is -5. The axis of symmetry is still the same, however, because we didn't move left or right. So the axis of symmetry is equal to the line x equals 0, right down the y-axis. So a horizontal translation, I didn't leave myself enough space. Translation of a parabola is a shift of the parabola left or right with no change in shape. And this refers to the value of h, right? If it's something like x minus h, you're going that direction. If it's like x plus h, we're talking about the squared part, you're going left. And it's basically the same rules as it was with absolute value. So hopefully the more and more you see this, as you see other functions in your math career, the rules still apply. So here we go. When h is bigger than 0, all right, we're going that way to the right, less than 0 to the left, and let's give this one a shot. So if we're looking at this function, right, the parent, here's the parent, 0, 0, 1, 1, 2, 4, and 3, 9. Here's the parent. And I'm not the best drawer. And let's see here. If we are moving everything, basically, in this scenario, we're moving it to the left. To the left, 1. So if we're moving everything to the left 1, right, our vertex changes from 0, 0 to -1, 0. And instead of -1, -1, we're at -2, 1. And you can kind of see like this shift occurring, right? -3 is going to be at 4. And, right, 0 is going to be here we go. I'm just going to shift everything over 1, because that's what's happening, right? When we're at 1, we're at 4, and 2, we're at 9, 3, so everything is has shifted over 1. And right over here, this goes right off the page on this point. This is basically off the page. So the function has a minimum value still, though, of 0, right? Because that didn't change. And the axis of symmetry has shifted to the line x is equal to -1. And that line is basically this, right down the middle of our translated parabola. And you can kind of see, right, it cuts it basically in half. So let's take a look at another example. So if our parent is right here, and I'm just drawing the parent right now, and let's see here, it's actually, this is going by twos, something like this. Sorry, 2, 4, 3, 9, 4, 16, and over here is going to be 16, and then right here, right there, 3, 9. So here you go. You got basically the parent function. Right, this is the parent, and that's y is equal to x squared. And h here tells us that this is going to move 2 to the right. So all I really have to do is shift everything 2 to the right, 2 to the right, 2 to the right, 2 to the right, and you kind of get the idea that once everything is moved over, 2 to the right, to the right, 2 to the right, you get the translated horizontal translation of the function. All right, it's just been moved over 2. And here we go again, right? Here's the basic shape of the parent. And right, that's the parent. And now this tells us, well, this translation means it's going to go 3 to the left. So I literally go 3 to the left for everything. So here we go, 3 to the left. 1, 2, 1, 3 to the left. I think I went too far on this one. 3 to the left. 3 to the left. No wonder this is confusing because, right, the top graph goes by 2s, but the bottom part of it goes by 3s, or goes by 1s. So here we go. 3. And sorry for all the erasing, but hopefully you get the idea, right? We're trying to shift everything 3, and if it's not perfect, that's okay. Don't worry so much about it. 2, 3, 1, 2, 3, 1, 2, 3. There we go. 3 to the right. And there you go. So let's see. Next up, we've got the vertex form of a quadratic function. Is basically, all this means is when f of x is equal to a times x minus h squared plus k. Right, we've already covered this. H and k are the vertex. The axis of symmetry is x is equal to whatever h is. So, and we've talked a little bit about how you can use the symmetry of a parabola. If you can graph half of it, you can graph the other half, because it's going to be symmetrical vertically along the axis of symmetry. And this paragraph here basically just describes that process. So now let's check it out in practice here. And if I pick, let's see, we know our vertex of this function here is going to be, our vertex is going to be 2, 4, right? Because that's H, that's K, there's A. So if our vertex is 2, 4, that's a good place to start in the middle. And let me find it here, 2, 4. There's the vertex. I know it's going to open up downward because of that negative. So let's try 0. So when I plug in 0 for this, it's going to be, well, 0 minus 2 is negative 2. Squared is 4. And a minus 4 and a positive 4 are 0. So there's that point. And if this vertex has an axis of symmetry, basically along x is equal to h, right? This here is the axis of symmetry, right? I know if this is 0, right, when I get to 4, that's going to be 0. Why? Because they're symmetrical. So let's try another point. How about negative 1? So negative 1 minus 2, I'm going to plug it in right there for x. Make a negative 3. Negative 3 squared is 9. 9 times a negative 1 is a negative 9. And negative 9 plus 4 is negative 5. So this next point is negative 1, negative 5, which is down here, which means the other point is also going to be over here. How come? Parabolas are symmetric. So that's going to be negative 5, and this point here is 5. So if you can graph half of it, you can graph the other half. So let's try this other example, right? Our vertex is going to be negative 3, right? Because there's H, there's K, and negative 1. A is positive, so this is going to open upwards. And let's find our vertex. Negative 3, negative 1. There it is. Negative 3, negative 1. I'm putting it in the middle because there's going to be an axis of symmetry basically all along this point in the vertex. So if I can find anything on this side, I can match it up with that side. So here we go. I don't know, 0 is a good place to start, or we can just go negative 2, negative 1, negative 4, negative 5. If I plug in a negative 2, right, you got negative 2 plus 3 is 1. 1 squared is 1. 1 times 2 is 2. And 2 minus 1 is 1. So if this side is 1, that side is 1, right, because it's symmetric. And now let's try negative 1. Negative 1 plus 3 is 2. 2 squared is 4. 4 times 2 is 8. And 8 minus 1 is 7. So here we go, negative 1 and 7. And if this is 7, that is 7. And there you go. There's another parabola. And this concludes this sections of notes, and we'll move on to guided practice.